Hello everyone, my name is Anushri, second year BE in Information Science and Engineering Department at Sri Venkateshwara College of Engineering, Bengaluru. Today's topic of my presentation is Huffman Coding. The contents are Huffman Coding, steps to build Huffman Tree and the algorithm, time complexity and space complexity, applications of Huffman Coding. So what is Huffman Coding? Huffman coding is a lossless data compression algorithm. The idea is to assign variable length codes to the input characters. Lengths of the assigned codes are based on the frequencies of the corresponding characters. So first, we will arrange the given characters frequency into the increasing order, and then we go on summing up the least frequencies one after the other to achieve the goal. The variable length codes assigned to the input characters are prefix codes, means the code's bit sequence are assigned in such a way that the code assigned to one character is not the prefix of the code assigned to the other character, which means the prefix codes of the each characters are very unique to one another. This is how Huffman coding makes sure that there is no ambiguity when coding the generated bit stream. Steps to build the Huffman tree. Input is an array of unique characters along with their frequency of occurrences, and output is Huffman tree. So first step is to create a leaf node for each unique character and build a min heap of all leaf nodes. Min heap is used as a priority queue. The value of the frequency field is used to compare the two nodes in min heap. Initially, the least frequent character is at the root. The second step is to extract two nodes with the minimum frequency from the min heap. As I already said, we will arrange the frequencies in the increasing order or a non-decreasing order, and then we go on summing up the frequencies which are minimum to see. So the third step is to create a new internal node with the frequency equal to the sum of a two nodes frequencies, making the first extracted node as its left child and the other extracted node which is later extracted as its right child. Add this node to the min heap. Repeat steps 2 and 3 until the heap contains only one node. The remaining node is the root node and the tree is complete. So let's understand with an example. Here we have characters A, B, C, D, E, F with the frequencies 5, 9, 12, 13, 16 and 45 respectively. So first step is to build a minimum heap that contains the 6 nodes where each node represents the root of a tree with a single node. So first we have the frequencies 5 and 9 of A and B characters which are minimum. So we sum up the 5 and 9 to get 14. So that is the min heap root. Here we have. In the step 2, extract two minimum frequency nodes from the min heap as I already said, and add a new internal node with the frequency 5 plus 9 is equals to 14. So then now the min heap contains 5 nodes with the 4 nodes are roots of a tree with a single element each, and the one heap is a root of a tree with 3 elements. So now again we arrange the character and the frequencies according to the increasing order of the frequencies. So now we have C, D internal node which we have created in the previous step, that is 14, and E and F with frequencies 12, 13, 14, 16 and 45 respectively. Step 3 is to extract two minimum frequencies, again nodes from the heap. Add a new internal node with the frequency 12 plus 13 is equals to 25. As I already said, then now we select the two characters C and D with the minimum frequency, that is 12 and 13, which have a minimum frequency, and we sum up those two to get 25 node. So that 25 node becomes the root, and we have the right children as D13 and the left child as the 12 with the C character. Now the min heap contains 4 nodes, where 2 nodes are the roots of a tree with a single element each, and the 2 heaps nodes are the root of the tree with more than 1 nodes. So now we arrange the characters and the frequencies again with the 2 internal nodes which we have created previously. So the internal node 1, which is 14, we obtain, and the one E internal node 25 and F with the frequency 45. Step 4 is to extract 2 minimum frequency nodes again repeatedly. Add a new internal node with a frequency 14 plus 16 is equals to 30. As I already said, now also we have the internal node 1 which I have created firstly as a 14 frequency, and E with the frequency of 16. We add those two because those two have the minimum frequencies nodes. So we add those two to get 30. So now the 30 has the right child E with the frequency 16, and the 30 has the left child with the 14, which indeed have the right child B with 9 and A with 5 as a left child. Now the heap contains 3 nodes. Though the characters internal node has 50 frequency, internal node 30 frequency, and F with the frequency 45. Extract 2 minimum frequency nodes, add a new internal node with a frequency 25 plus 30 is equals to 55. So now again we select the 2 frequencies, that is internal node frequency. So internal node second we have created, and the third internal node which we have created with the frequencies 25 and 30 which have the minimum frequencies. So we can select those two to get the sum 55. Here 55 has the right child as 30 with the left child 30, which indeed has the right child 16, that is E character, and the left child as 14 with a 14 having left child as A with a 5 frequency and a right child as a B with a 9 frequency. Then the main root node 55 has the left child as 25, 25 has the left child as C with the frequency 12, and then we have the D with the right child of a 25, that is frequency 13. Then now we have the character frequency table as F with 45 and internal node which have created previously with 55. Extract 2 minimum frequency nodes as we already have only those two. So to sum up, so we sum up 45 plus 55 which gives us 100. 100 has the left child as F with a 45 frequency and right child as 55 with the frequency. So now we have the 55 also with the right child and left child respectively. Steps to print the codes from Huffman Tree. Traverse the tree formed starting from the root, maintain an auxiliary array. While moving to the left child, write 0 to the array. We order all the left child with the zeros and the right child with the 1. We assign the value 1 for the right children and then 0 for the left children. While moving to the right child, write 1 to the array. Print the array when a leaf node is encountered. Algorithm. The method which is used to construct the optimal prefix code is called as the Huffman coding. The algorithm builds a tree in a bottom-up manner. We denote this tree by T. Let C be the number of leaves, C minus 1 are number of operations required to merge the nodes, Q be the priority queue, which can be used while constructing the binary heap. So here we use the priority queue to constructing the binary heap. So algorithm goes like this. We first begin, then define a node with a character frequency, left and right child of the node for a Huffman tree. Create a list frequency to store the frequency of each character. Initially, all are 0. For each character in a C in the string, do increase the frequency for the character CH in the list. Thus, because we add the 2 frequencies of elements or a character, so we increase the frequencies of the elements. So done. For all type of characters CH, do if the frequency of the character is non-zero, then add the character and its frequency as a node of the priority queue. Thus, we have this sum as the node and which is added to the priority queue. Done. While queue is not empty, do remove the item from the queue and assign it to the left child of the node. Remove the item from the queue and assign to the right child of the node. After constructing the heap of the node, we actually construct the left and right child of this node. So they traverse the node to find the assigned code, and that's done. End the code. Algorithm we have n is equals to c. So q is equal to c for from I is equals to -1 to n minus 1. That is number of nodes minus characters minus 1. Do temp is equals to get node. First we'll get the node, and then left temp get min of q, right? Temp get min of q. A is equals to left of temp. B is equals to right of temp. We transfer the right of the temp value, right of temp value to the left temp, and then we can transfer that left value of that thing to the A. F of temp is equal to f of A plus B. Insert Q and temp. Return get minimum of 0. Time complexity and space complexity. Time complexity. We go of n log n, where n is the number of unique characters. If there are n nodes, extract minimum is called as 2 into n minus 1 times extract min takes big O of log n times as it calls min hippify. So the overall complexity is big O of n log n. If the input array is sorted, there exists a linear time algorithm. Space complexity is big O of n. Applications of Huffman code. These are used for transmitting facts and the text. They are used for the conventional compression formats like pkzip and gzip, etc. Multimedia codecs like JPEG and PNG and MP3 are used the Huffman encoding to be more precisely prefix codes. It's useful in cases where there is a series of frequently occurring characters. It is also used to encryption of the data. While encoding and coding, it saves the data from being corrupted. Thank you.